There we go. And third box down is there. Okay, so in the diagram, HL and KT intersect at the midpoint of HL. Okay, so let's start drawing our pictures and marking them up. From that statement, I know that that side's equal to that side, correct?
Right.
All I know at the moment. Classify each statement as true or false. Km must equal MT. Well, it didn't say that it bisected KT. It said that KT bisected HL. So the only thing in other words, you can have one line bisect another and the other line doesn't bisect this one. This does not have to be the same distance as that. Notice that I could put K way over there. Now it's definitely not the same distance. For that matter, it goes on forever. I could make K way down there. And now Km is definitely not equal to MT. In this picture, it looks like it could be. In other words, they have drawn it in a way where it does look like it's equal to it. But you can't tell it. The only thing you know is that.
Okay.
Let's look at 8. Let's just go through each of these. KT is a bisector of LH, correct? MT and MK are opposite rays.
That is true.
Yeah, no, that's true. KT is the same as KM. What? KT is the same as KM. Well, that's false. Obviously, KT is that entire line, and KM is just that piece of it.
All right.
Okay. KT is the same as KM. It's the same thing. What am I missing? Oh, now I get it. This says ray KT is the same as ray KM.
That's true.
Why?
Because they're on the same line.
Now hold on. You're saying ray KT is the same as ray KM. Okay. So by the definition of rays, if they're on the same line, they don't have a finite length and they're basically infinite, both of them? Is that what you're saying?
Yeah.
Okay. Whereas 14 says the line segment KT is the same as the line segment KM. That's definitely not true. I think you might have these backwards. Here, let's talk about this. Let's look at 12. If one is true and one is false, then the true one's got to be 12. The 14 is definitely false. This line means the line segment, KT. Well, that's the line segment, KT. Okay? This means the line segment, KM. Well, KM is just that piece of the line. They're definitely not the same. Now, if we go back to the previous problem, number 12, the difference is they're talking about not a line segment, but the entire line. So I guess when you define the ray Km, it goes to infinity in both directions. So I could call that the ray Km. It's also the ray KT. In other words, the ray KT goes in both directions to infinity. So I would believe that the rays are the same. So to me, that one's true and this one is false. But this is something that I haven't come across that much in geometry. You're getting it probably because you're in honors. But the difference between a ray and a line segment. When I first looked at this, I thought that there was a typo because they put the same question in there twice. But I do understand. Wow. If we look at number 10, tell me something. The ray MT, does that start there and go there?
Yes.
Well, then that ray is not the same as the ray TK or MK. In other words, MK starts at M and goes in that direction. MT goes in that direction. Okay, so they're opposite rays. The question is 12, and I'm going to be perfectly honest with you. I'm not positive. Now see up here, this designation there, where they put a double arrow above it,
Yeah.
that means that entire line. I know that much. In other words, the double arrow means,
It goes on forever.
yeah, in both directions. That is the double ray KT. So if they're using a single ray, MT, it can only be a ray that starts at M. In other words, that ray has to start there. It doesn't go down and to the left forever. It just goes up and forever.
Okay.
So MT, the ray, that would be that ray, MT. It even tells you it goes in the direction of T. And MK starts at that same spot but goes in the other direction forever. So they're definitely opposite rays. I would say KT is not the same as MK. Here's why, I think. I mean, I don't know. I don't know how you compare infinite lengths. First of all, here. These are bizarre questions, actually. But if I look at KT, I'm going to start at K, I'm going to go towards T, and I'm going to go on forever. That is KT. Notice it is not the same as MT.
Right.
And KM, the ray KM, starts at K, goes towards M, and goes on forever. So those are equal.
So they are opposite.
Are definitely not opposite. Well, 10 is true, but 12 is true also.
All right.
In other words, KT, I just drew KT on the right, and I would have drawn KM right on top of it. the fact that it's got this arrow here means it does not stop at M. It goes on forever. The exact same thing that KT does. So those are true, and that's definitely false. Now let's look at 16. Let me erase everything. Tm plus mh equals th. So they're saying Tm, the length of that, plus mh, the length of that, equals th. True or false? False, clearly.
And for number 18, I meant to say true.
What's that?
For number 18, I meant to say true.
Okay. M, let me look at it without all my scribbling on there. M is between K and T. Yeah, it is. We don't know that it's halfway in between, but it's definitely in between.
Yep.
Okay. Let's go down. Should we just scroll down here?
Sure.
Just to make sure that these are correct. Let's see. FOB is 50. Given the diagram, state whether you can reach the conclusion the measurement of FOB is 50. Yes. The measurement of AOC is 90. Correct. Why?
Because it's a 90-degree angle.
They don't. No, they don't tell you it's a 90-degree angle. In other words, if they had that little sign right there, then that would be true.
Oh, wait, I was right then.
Yes, you are right. We don't know. We cannot reach that conclusion that angle AOC is a right angle. So 30. DOC. Yes, that's a straight line. So that is 180. AO equals OB. They're saying that segment equals that segment. Why?
No.
I don't see anywhere in this thing that indicates anything is being bisected.
So it's no?
I would say no, yeah.
Mm-hmm.
Merely because we don't have any information that indicates that it's yes. You can't say something, you can't reach a conclusion unless you have some sort of proof. And at this point, there's not a lot of information they've given us. Unless I'm missing something here, they've given us 50 degrees and that's it. We don't know what that angle, we don't know what this angle is, we don't know what this angle is. We can tell that that's 50 because that's a vertical angle. And I know that DOB is the same as AOC, but I don't know what it is. I don't know if it's 90 or 91 or 89. Okay, so AOC is congruent to BOC. AOC and BOC. Yes, they are congruent. Oh, excuse me. No, they're not. I apologize. I was thinking they are add to 180.
Mm-hmm.
But they're supplementary, but they're not. That's not what it says. It says congruent. In other words, the only way we would know that is if we knew that AOC was 90 degrees. Then that would be true. But we have no indication of that. So no is correct. Sorry, I took so long on that one. Measurement of AOF is 130. That is correct. Points E, O, and F. E, O, and F are collinear. They are. They are on the same line. That's what collinear means. E, O, and F. I'm assuming that every line we're looking at here is a straight line.
Yeah.
In other words, all of these require you to understand that they're straight lines. And that's probably what these arrows on each end indicate, is that's a straight line. CD is a straight line. Okay, so that's a yes. They are collinear. Point C is in the interior of angle AOF. Well, there's point C. AOF. By being in the interior, I assume they mean on the inside of the angle as opposed to out here, which would be exterior.
Okay, so that is.
Yeah, I would say yes. I'm trying to figure out how you would define it mathematically. In other words, as long as that goes forever in both directions, then any point that would fall in this region out to infinities everywhere, that's going to be the interior of that angle. Whereas, like I said, if I had a point over there, that would not be.
Okay.
AOE and AOD. AOE is that one. AOD is that one. They're not adjacent angles.
No.
I hope you're making these notes as we go along, because I erased it so that I can keep writing. So
Yeah,
I erased all the changed answers. Okay, just tell me which angles are adjacent in that picture, in that area.
In EOD.
Is adjacent to AOE, yes. In other words, adjacent means they share one ray. But one does not encompass the other. Okay. AOB is a straight angle, yes. OA and OB are opposite rays. Certainly yes, assuming that that is also correct by the same reasoning. All right, next page. These are in order, or do you know? Here, let's load it up and see if we can read a page number at the bottom of it. Yes, page 2.
I don't think I did like this right because I was just like kind of like putting the information down. I wasn't really answering it.
Okay. Well, we'll go over all of it using deductive reasoning. These are definitely geometry questions that only the honor students. I've been teaching quite a few geometry students, and I haven't seen questions like this. Who's your teacher?
Miss Paulus.
Okay. Because Mr. Moore is also an honors geometry teacher, correct?
At Mullen?
Oh, I forgot. You don't go to Chatfield yet.
No.
Oh, that's right. You know, I assumed you, yeah. My apologies. That's why I'm seeing these questions. I have never tutored an honors geometry student from Mullen. I've
Yeah.
tutored them from Chatfield before, and you don't see these kind of questions. So this is different for me, but I think we can figure it out. It's not that hard. So what's the hypothesis?
It's the if AB and CD intersect.
Okay, and the conclusion?
It's then ray AB and ray CD intersect.
Okay. So you got number one. Number two, write the converse of the conditional. That's the conditional. What's the converse of it?
The if AB and CD intersect, then line AB and line CD intersect.
Yeah, I think. Are you sure about that?
Yeah.
This is another one where the terminology, I don't know all the terminology. I know one is the converse, the other is the biconditional. No, I don't see the other on here anywhere. Okay, so the converse is just reversing the hypothesis and the conclusion. Is the converse true or false?
True.
It's not always true. If P then Q does not mean if...
Well, yeah, I know, but this particular is.
What's that?
I know that, but like...
Okay. In other words, the converse of the conditional is not always true. If you live in Colorado, you live in the United States, does not mean that if you live in the United States, you live in Colorado.
Yeah.
So normally, the converse is a fake. Most people think it's true in real life, but it just isn't always. So in this case, let's see, if I have two line segments that intersect, that's your hypothesis, then the ray AB would have to intersect with the ray CD. Okay, and now I guess if I look at the converse, if the two rays intersect, then the two line segments have to intersect. Now again, let me think about that for a moment. What if we make that point A and that point B? And we're going to make that point C and that point D. So AB, but then AB doesn't intersect with CD either. So let me make sure that one of these is slightly different. Let's put A over here. And erase it from where I had it. So lines, no, it still wouldn't. So yeah, I guess it's true. Is the converse true or false? I think it's true. And I come up with that because I can't draw it in a way that it's not true.
Yeah.
Right? In other words, no matter where I label my points A, B, and C, D, the ray AB, which goes from there to there, doesn't or the line segment AB does not intersect with CD. So this can't even be an example. I've got to make the two line segments intersect also. So I've got to put C on the other side. In other words, now the hypothesis is true. CD, line segment CD intersects line segment AB. And can I draw the rays so that the rays intersect but the line segments don't? I don't think so. Yeah, can't I? No, I can. You tell me here, since I'm a little unfamiliar with the terminology here. Does ray CD intersect ray AB?
Well, can't C go on the other side too? So then if you do that, then it's yes.
CD doesn't begin, it has to begin right there because it doesn't have the double arrow top. In other words, CD is only going to be like that, correct?
Well, can't you put C on the other side of AB?
Well, you could, but what I'm trying to do is come up with a situation where this is not true. In other words, because I guess this ray would not intersect with ray AB by my rationale. In other words, those two rays don't intersect. So if the two rays intersect, then I think the two line segments have to intersect. So let's go with true on that. Not spend any more time. I don't want to waste your time with my lack of expertise on this particular material. Rewrite the following pairs of conditionals as biconditionals. Biconditionals means that the converse is always true, correct?
Right.
In other words, it's if and only if. So if AB is congruent to CD, if AB is equal to CD, then AB is congruent to CD only if AB is congruent to CD. Rewrite the following pairs of conditionals as biconditional. Well, how would you rewrite it? In other words, right now I've got two conditionals. I've got that one, and I've got that one. I think you only need to add one word. If and only if.
Yeah.
Because the only if isn't enough. Well, it doesn't say the same thing as biconditional. If I say only if, that means AB has to be equal to CD for AB to be congruent to CD.
Right.
But this one says that if AB is congruent to CD, if AB equals CD, I think these say the same thing. Gosh. Rewrite the following pair of conditionals as a biconditional. Well, the obvious answer is if and only if. And I don't think it matters which one goes first. In other words, when you have a biconditional, I can reverse these. I could say AB is equal to CD if and only if AB is congruent to CD. And I could state it like this that I've got in the rectangle also.
Okay.
If and only if is the words that are key. Only if might kind of mean the same thing. Again, hope I'm not steering you wrong here, Janessa, but we'll keep going. Okay. Provide a counterexample to disprove the statement. These are easier. If angle the measurement of angle A is less than 100, then angle A is an acute angle. So give me something that disproves that. Give me an angle A that disproves that statement.
50.
That would be an acute angle.
Yeah.
That doesn't disprove it. How about this one? If angle A were equal to 95 degrees, that disproves it.
Oh.
That it satisfies that part, it's less than 100, but it's not acute.
I get it. I was reading it wrong.
So you have to find an example that disproves the statement. So you have to find something that satisfies the hypothesis and doesn't satisfy the condition. Number 5. Okay. What property of equality justifies the fact that angle A plus angle C equals 180? Remember your properties of equalities, the reflexive, the transitive, all of those. Which one is this?
Transitive?
My first answer was substitution.
But they're like the same thing, right?
I think they are. You'd have to look it up. So this is another area where these equality properties, I always have to look up. I don't know why I can't remember them, but let's look them up. I think I even know where they are in the book, just to make sure we have it right. I even took a picture of them once and moved it to my computer, but I have no idea where it's at on my computer. It'd be easier for me to find if I look in the book. In fact, probably the index. I need properties of equality. No. Who knew? Properties of algebraic, okay, 96 and 97. Thank you. All right, here we go. There actually is a substitution property.
Yeah.
But it's also the transitive. The transitive says if A is equal to B and B is equal to C, then A is equal to C. And that's what we're looking at here, I believe. Which one are we on here? We're on number 5. If A plus B equals 180 and C is equal to B, then we're substituting C for B so that A plus C would equal 180. I don't think that is the transitive. I think that's the substitution, strictly. I don't believe that these other properties, I don't think they would have it in my book separately. I've got 8 properties. I've got addition, subtraction, multiplication, division, and I got reflexive, symmetric, transitive, and then it's got an 8th one, substitution. I think this is just the substitution property.
Just substitution?
I think that's what it is for number 5. Which property? What property of equality justifies that? It's not the transitive. The transitive is this, basically. If A equals B and B equals C, then I can say that A equals C. Now, I guess I could call that the substitution property also. In other words, the transitive property uses the substitution property, right?
Yeah.
In other words, if B is equal to C, then I can substitute C wherever I see B. So I could make that statement and justify it using either the transitive property or the substitution property. I don't understand why I wouldn't be able to use both. But this problem's a little different. This says A plus B equals 180, and then it says C is equal to B. So it's not really the transitive property. It's more the substitution, I think. I don't know for sure, but I would say substitution, not the transitive. I will leave that page open in case we need it.
Okay.
Number 6. Point M is the midpoint of RT. Now let's draw RT. And M is the midpoint. RM is X. RT is 4X minus, RT. So this side from here to there is 4x minus 6. Find the value of x. What are they doing with a normal looking geometry problem in here? That's not Mullen-esque.
Nope.
So how do we solve this?
We're just trying to find x, so. Well, like half of 4x minus 6 equals x.
There you go. Let's write that as an equation. 1/2 of 4x minus 6 equals x. Now solve that.
Well, we multiply by 2, so just be 2x on the other side, then 4x minus 6. Then you can add 6 to the other side, so 2x equals 6, then x would equal 3.
There you go. Like I said, what are they doing with a normal looking geometry problem? And you could write that equation multiple ways. First of all, I also know that that's equal to x, correct? If M is the midpoint. And now I can just say that that x plus that x has to equal 4x minus 6. So there's multiple avenues of attack. Ultimately, they're all pretty much the same. So, all right. Number 7. Measure of ABC is 108. Let's draw it like this. And ABC. BD is the bisector. So BD is the bisector, making that angle equal to that angle, making each of those angles what? Let's see, what are they asking? And BE is the bisector of ABD. so there's another line right here, BE, and that angle is equal to that angle. I got everything right? I think so. Now we should be able to answer whatever question they ask.
All right.
Find the measure of EBC. Well, let's just find the measures of all the angles we're looking at. What's this one right here?
Right where?
Where I got the check mark. What's that angle?
What's like what like
Remember what the 108 is. The 108 is ABC.
ABC, okay.
So let me cross that out because it's confusing now. The 108 number. However, everything else I have there is correct. And just here, let's label ABC is 108. Okay. So now tell me what DBC is. What is DBC? D as in David, boy, Cowan. If BD is a bisector of ABC, then what does DBC have to be?
54.
Okay. And what does ABD have to be? In other words, from there to there.
54 too.
54. Now, what are these two angles that I've got double hash marked angle marks on each one? What are they?
Congruent.
What's the measurement? Because BE bisects ABD.
27.
Okay, so that's 27, that's 27. And now they want to know what EBC is.
EBC is 82.
81. It's 27 plus 54. Always remember when you're adding an odd number to an even number, you're going to get an odd number.
Right, okay.
You're never going to get an even number. To get an even number, you have to add an even to an even or an odd to an odd. But when you add an odd and an even, you're always going to get an odd. So that's why it can't be 82. That's the only reason I said that.
Okay.
When you're doing mental math sometimes, you don't want to be off by 1. Okay, so number 8. Let's see. You can use given information and theorems as reasons and proofs. Name 2 other kinds of reasons you can use.
Like theorems. But that's already there.
I can think of at least one. Funny sounding one, CPCTC.
Oh yeah, I can read corresponding parts with you. Yeah.
And that's not a theorem, I don't believe. Is it?
No.
No. So that's definitely one other kind of reason you can use. In other words, they're saying what goes in the right column always. In other words, you have your statements and you have your reasons in a 2-column proof. And one of the reasons is always given, the first one usually. And a lot of them are theorems. How about postulates?
Oh, that's right. Postulates.
Postulates. Not quite sure what the difference between a postulate and a theorem is. Or for that matter, a corollary also. Corollary generally means if it works one way, it works the other also.
Okay.
In other words, if I said a right triangle satisfies the Pythagorean theorem such that a squared plus b squared equals c squared, that is the Pythagorean theorem. But the corollary to that is that if a squared plus b squared equals c squared, then you have a right triangle also. You have to. In other words, you can't have this be satisfied without having a right triangle. So this is kind of an if and only if. And I think all corollaries are probably ifs and only ifs of the theorems or postulates. But I believe we've got three. We got that, we got postulates, we got corollaries. We even have equality properties of equality, sorry.
Okay.
We have properties of equality. In other words, the transitive, those aren't theorems. So I think we just named 4 other ways besides givens and theorems. Scroll down. Oh, I love these problems. Actually, I do, given the ones you've showed me so far. I haven't loved those at all.
Yeah.
Well, they just are, I don't know. Their differentiation between rays and line segments and all of that seems to me a little excessive, but okay. Write something you can conclude from the given information. Angle 1 is equal to angle 4. These were pre-labeled already, right? That's 1, 2, 3, 4. You didn't write those in?
No, I did not.
Okay, so if angle 1 is equal to angle 4, that's what that says, then angle 2 is equal to angle 3. Oh, that's the given.
Yeah.
It's not then. I misread it. It's not if angle 1 is equal to angle 4, then angle 2 is equal to angle 3. That's what I thought they were saying. They're saying that that is true. In other words, that angle is equal to that angle. Okay, so what can we conclude from that? Something, anything at all.
That they're equal. Like angle.
I guess you could, no, because they're telling you the measurements are equal already. Okay, so your conclusion is that they are also congruent.
Yes.
Yeah, in other words, your conclusion is that angle 1 is congruent to angle 4, right?
Right.
You conclude that? Yes, you can. Congruency is an if and only if with the measurement of the angle. In other words, if they're congruent, the measurements are the same, and if the measurements are the same, they're congruent. So you can definitely tell they're congruent, both of them. So you could make 2 congruent statements. You could also say something else. You could say triangle BCE is isosceles.
Okay.
You could also, no, you cannot conclude that that's parallel to that. In other words, we don't know that angle 4 is the same as angle F. If we did, then we could conclude that BF is parallel to CG. But it doesn't say that. And I guess you only have to write one thing, right?
Yeah.
It doesn't say write everything that you can conclude from the given information. So
No, just
we'll just do one and go on. We did two at least. Okay, now starting from scratch again, right? In other
right.
words, when I'm looking at number two, I can't, the given is not number one also. The only given on number two is that AB is equal to CD, right?
Right.
So
That's a different.
AB, that segment, is equal to that segment. And you're concluding that AB is 90 degrees.
I don't really know how I got that.
Well, that doesn't make any sense anyway, because AB does not define an angle. So if you're going to say something is equal to 90 degrees, it has to either be a single letter like F, or it has to be three letters. But AB is a straight line, so there's no angle measurement. If anything, it would be 180. But let's look at that picture and see what we can conclude. That is the same length as that. I don't see anything we can conclude. Does there have to be something for everyone?
I thought so.
Given AB is equal to CD, I suppose you could say that ray CD, or excuse me, CA, going from C to A, the ray, is the same as the ray going from B to D. In other words, if we look at the ray, if I draw them in different colors here, I'll draw them in really different colors. If we look at CA, that ray, that is that ray right there. And if we look at that's CA, but if we look at BD, it would be that one beginning right there. No, I know what we can say. Just occurred to me. We can say that AC equals BD. Right? And here's the proof. AC is AB plus BC. So we got AC equals AB plus BC. And we've got BD is equal to BC plus CD. And then they're telling us that AB is equal to CD, so that's a given. And now by substitution, wherever I see AB, I can substitute CD. And BC is equal to itself.
Right.
Hold on a minute. Yeah, BC is equal to itself. So if AB equals CD, then I can substitute AB. And BD is definitely BC plus AB. And
Okay.
AC is definitely AB plus BC. There's the same. Okay?
Okay.
Therefore, AC is equal to BD. Yeah, that's the only thing I think you can write. There may be other things, but that one I'm sure of. And only reason you can say that is because AB is equal to CD. And BC is equal to itself. So, all right, let's put a temporary halt to this torture. And we'll try to remember where we left off. I don't think I'll have any problem.
Okay.
It's, yeah, with number 3 on this figure over here. So we can get back to this next time. All
All
right,
right.
Tessa,
Thank you.
you're welcome.
All right.
Sorry I couldn't have been a little more helpful, but
That's okay.
it's Mullen.
Yeah.
All right, bye-bye.
Bye.